So, hello student, good morning to all of you. So, in today's class, we are going to start our new chapter, that is projectile motion. In yesterday's class, we have studied about motion in one-dimensional chapter, in which we have studied about the objects which are traveling in a straight motion, or the object which can do a linear motion in only one axis, one of the coordinate axis. So, let's just start our new chapter, that is projectile motion. To write on the heading projectile motion. Projectile motion. So before getting started this chapter, let's remind something that this lecture is going to be completely in English, and please listen me very carefully to understand each and every concept regarding this chapter. And we are trying to solve as many as numerical as possible, and I can also create some of the formulas and also prepare some of the numericals for you students. So without wasting any time, let's start our topic, that is projectile motion. So this is a type of 2D motion. So let us understand what is the 2D motion. So suppose this whiteboard is a plane. This whiteboard is a plane, and these are the three objects. This is the object A, this is the object B, this is the object A, this is the object B, and this is the object C. If the object A is traveling in the x-axis, this is the x-axis of a plane, and object B is traveling along y-axis. Object A is traveling along x-axis, and object B is traveling along y-axis, and object C is traveling along z-axis. Like this. So if we find the change in all the three of the coordinate axes, then we describe this type of motion, three-dimensional motion. But in this chapter, we have only discussed about 2D motion, in which we find change in only two of the coordinate axes. Like this is the x-axis of plane, this is the y-axis, and if object A is traveling along x-axis and object B is traveling along y-axis. So if we find the change in along x-axis and y-axis, then we describe this type of motion in two-dimensional motion. So projectile motion is a two-dimensional motion. It's example of two-dimensional motion. So the projectile motion, the path of projectile motion is parabolic path, and a parabolic path is always composed of two of the motion, like composed of vertical motion as well as horizontal motion plus horizontal motion. Let us divide this board into three of the parts to write maximum things in this whiteboard. So our parabolic path composed of both the motion, first of all vertical motion and horizontal motion. So let us take an example like this. Let us suppose this is the object O, and this is the x-axis. This is the x-axis. This is the y-axis. Okay. So we can throw this object O. Let us suppose this object O be a ball or be a stone. So we can throw this ball along x-axis with an initial velocity, that is u, and the angle of inclination is theta. This is the angle of inclination, means the angle in which the object is to incline. I hope this is to be clear. So the initial velocity is u, and this is the x-axis, this is the x-axis, and this is the y-axis. This is the y-axis, like this. So the component along x-axis is ux. What? Ux. The component along y-axis, this is uy. Uy is the vertical component and ux is the horizontal component. I hope this is clear to you. So the value of ux is u cos theta. What? U cos theta. And the value of uy is the vertical component is u sin theta. I hope this is clear to you all. So you may ask me one question, okay sir, why we do not take u sin theta here and why why we do not take u cos theta here? So in trigonometry we will study about sin theta and cos theta. Sin theta is perpendicular upon hypotenuse. Sin theta is simply perpendicular upon hypotenuse. Upon hypotenuse means perpendicular. This is the perpendicular. This is the perpendicular along x-axis and hypotenuse means the velocity. So sin theta is component along perpendicular and hypotenuse. Sin theta creates a relation between perpendicular and hypotenuse. So this is the only reason we take sin theta here. And cos theta means based upon hypotenuse. Cos theta means based upon hypotenuse. Based upon hypotenuse. So this is the base. This is the base. This x-axis is the base, and this is the hypotenuse. The velocity component u. The initial velocity, that is the u. So this is the only component. Cos theta is only trigonometric ratio that can create a relationship between base and hypotenuse. This is the only reason we take cos theta here. I hope this is clear to you all. So this is the very basic things. I think you never find any type of confusion regarding this. So through the diagram we can understand some more things like this is the height, this is the height, and this is the maximum height, x max. And one more thing, that is this is the entire projectile. This is the project initial. This is the simplest diagram of any projectile. So we can conclude some of the things like a projectile always follows a circular path or parabolic path. I hope this is clear to you all. Always a projectile follows a circular path or a parabolic path, in which the ui component, like this is the ui component along y-axis. This is the vertical component, and the ux component remains constant along this. So we can create another diagram to understand it carefully. So let us draw a diagram like this. This projectile will put two type of component. One vertical component. Let us take this is the initial velocity bu, and this is the vertical component like this. So I hope this is clear to you all. This is the vertical component. The initial velocity bu. This is the vertical component ui. Vertical component. And this is the horizontal component. The initial velocity bu. This is the horizontal component along x-axis. Along x-axis. This is along y-axis. So we feel a type of acceleration when we move upward. So the value of acceleration is a is equal to minus g. And along x-axis there is no any type of acceleration. Means the value of acceleration is to be 0, or we say acceleration is remains constant along x-axis. I hope this clear to you all. So if we draw a diagram like this, let us suppose this is projectile. This is your projectile. So this is a projectile, and this is the x-axis. This is the x-axis. This is the y-axis. This is the y-axis. Let us draw a straight line like this. This is the y-axis. The component along x-axis is ux. The component along y-axis is uy. I hope this clear to you all. This is the ux means u cos theta. Ui component is u sin theta. Theta is the angle of inclination. Let us suppose the object be O, a ball or a stone. We can throw a stone at an angle theta, and it covers a distance r. This is the r, means range. So these are the basic terms like range. This is the height of any projectile. This is the height of any projectile. What? This is the height, and always say the maximum height. the range. Range means the total distance covered by a projectile is to be known as the range of projectile. And the time of flight. One more thing we can understand, like the time of flight. Time of flight is the total time taken by a projectile in which it remains in air before touching the ground. This is the total time of flight. We can try the formula of time of flight also. So let us understand some basic things in the diagram, that US cos theta. So the value of US cos theta remains constant at any other point. Like this, the value of UX is remains constant, but UI will changes. The value of UX is US cos theta at this point, but the value of UI is not UI sin theta. It's not U sin theta at this point. Why? Because at this point, a type of acceleration that is minus g, x on it. This is the only reason the horizontal component remains constant at any other point. Like this, in this point, the ux component remains same, and the uy component may decreases. I hope this is clear to you all. So uy component means the velocity may decreases uy, or we say vy, anything. So at this point uy becomes 0. Uy component becomes 0. Means the velocity along y-axis becomes 0. Why? Give me the answer. The only reason the velocity along y-axis becomes 0 is that there is a type of acceleration along y-axis, a is equal to minus g. I hope this is clear to you all. So write a small note that ui, will decrease as ui, the initial velocity along vy. Ui may along y-axis, this is the most important line, or in vertical direction, or we say in vertical direction, may first decreases and then increases. The only reason that the initial velocity ui along y-axis will decreases because in vertical direction we feel a type of acceleration, that is the minus g along y-axis, but the acceleration remains constant along x-axis. So the value of ux at any of the point remains to be constant. Ux, that is u cos theta, at any of the point remains constant, or we take the value of u cos theta like this. Ux, uy, the value of uy now increases. It increases at this point, and it remains constant. I hope this is clear to you all. It remains constant, but the value of uy first decreases, and then becomes 0, and now it becomes increases. I hope this is clear to you all. So this is the basic diagram of any projectile. I hope this is to be clear that there are some of the terms like time of flight, like range. Range is the range is the total distance covered by a projectile. So, and one more thing, range, time of flight, and height. Height is the height, the vertical distance traveled by a projectile. So I hope this is clear to you all. So let us derive some formulas like of time of flight and range and height of projectile. So without wasting any time, let us write down the heading time of flight. First, time of flight. Time of flight. that is denoted by T, capital T. So when we have to derive the formula of time of flight, so we can only consider the vertical direction of a projectile. Projectile, or we say we can consider only the vertical direction. Why? Give me the answer. Give me the answer. Why? The only reason is that in horizontal direction the acceleration remains constant. So there is no need to consider the horizontal direction or horizontal component when we have to derive the formula of time of flight. So right on the right, let us consider the vertical component of any projectile. So let us suppose the initial velocity be u. So this is going like this in vertically upward direction, and then it comes in vertically downward direction like this. So this is an object O, like a ball or a stone. So when we throw a stone at an angle theta, let us suppose with the velocity, initial velocity be u, then firstly it go upwards, and now at this point it becomes 0. The velocity may decreases first, and then it increases, and the velocity may go downwards, vertically downwards. So the time taken to go upward is t1. That is the value of t1 is u by g. What? The value of t1 is the time, t1 is the total time a projectile is to be taken to go in vertically upward direction, and t2 is the total time taken by a projectile in going in downward direction. So when we have to calculate the time of flight, so time of flight is the total time taken by the projectile to go in upward, and the total time taken by the projectile to go in the downward direction. So time of flight is the total time t. So when we have to derive the formula of t, that the t is equal to t1 plus t2. So the value of t1, let us substitute the value of t1, that is u by g. What? And the value of t2 is also u by g. Then the formula that is comes as 2u by g. One of the major mistakes that can done by the student or as well as the teacher. So the mistake is that the u is along y-axis. This is the vertical component. So that not u, that is uy. What? Like uy, this is the uy. Y component, this is uy. So write uy. That is uy. So this is the formula, and in many of the books you may study like, let us substitute the value of uy, that is the u sin theta. So after substituting the value of uy, u sin theta, we can get the value of time of flight, that is t is equal to 2u sin theta upon g. 2u sin theta upon g. I hope this is clear to you all. So whenever you will find any type of numerical related to time of flight, put the formula and get the answer. I hope this is clear to you all. So this is the basic formula of time of flight. So let us derive another formula for range. Range means the total distance covered by a projectile. So please note it down first. So my next topic is range. So you may pause the video and note it down, I think. So we may not waste any of the time. So my next heading is, you may write down the heading, next heading that range of projectile. What? Range of projectile. I will write down the heading, range of a projectile. Range of a projectile. So whenever you may have to calculate the range of projectile. So firstly understand what is the range. You have to understand the time of flight. Time of flight is total time taken by the projectile when it remains in air before reaching the ground. This is total time. How much time it will take to reach at this point. This is the time of flight. And firstly understand the definition of range of projectile. Range means the total. Write down the definition of range of projectile. Write down please. The range of projectile is the total distance traveled by a projectile. Let us suppose our projectile be a stone or a ball. So the total distance traveled by a stone or a ball or a projectile, the maximum distance it can cover it should be known as the range of projectile. I hope this clear to you all. So whenever we have to calculate the formula for range of projectile, so we can consider the vertical motion as well as the horizontal motion. We can consider both the component in range because in range we can consider the vertical component of any projectile and we can consider the horizontal component as well, ux and uy. I hope this is clear to you all. So whenever we have to derive the formula, firstly write down that we may consider both of the component. We may consider the horizontal component and vertical component as well as vertical component of any projectile. I hope this clear to you all. So whenever we have to derive the formula for range, that is the R. So 2 times of ux means the horizontal component, uy means the vertical component upon g. So substitute the value of ux and uy, you may get the answer. That is very simple. So first substitute the value of ux. The value of ux is u cos theta. The value of uy is u sin theta. So substitute the value and get the answer. Simple. It is as simple as that. So to u cos theta, value ux, uy, u sin theta upon g. So take the 2 inside, that is the u 2 sin theta cos theta. This can become the formula for sin theta. In mathematics, you have studied about formula of sin theta. That is the 2 sin theta cos theta. 2 sin theta cos theta. I hope this is clear to you all. So it becomes u 2 sin theta upon g. That is u square. Means u square. It becomes u square. I hope this is clear to you all. One minor mistake we can do in this formula. U square. That is u and u becomes u square sin theta upon g. So this is the formula for range of projectile. So whenever you will find a numerical related to range of projectile, you have to calculate the range for range of projectile. You can put this formula and get the answer. I hope this is clear to you all. So one more question, that is you may ask one question that if any person may ask, okay, at which angle we have to throw a stone, we can throw an object that will cover the maximum range. Means you have to find the formula for R max, maximum range now. So whenever we have to calculate the formula for maximum range, R max means R max. So note it down very carefully. Sine gives its maximum value at 90. So if the value of theta becomes 45 degree, so 45 into 2 it becomes sine 90, and you may find the maximum range like this. R max. R max means u square sine. Let take the value of theta to 45 degree. Means at theta is equal to 45 degree, you may find the maximum range. That is the u square sine 45 upon g. Means it becomes 1 sine 90. The value of sine 90 is equal to 1. The maximum value of sine. So u square upon g. The formula of R max. I hope this is clear to you all. I hope this is clear to you all. So draw a box and please remind this formula. This is a very important formula. So whenever you will find any type of numerical related to range, maximum range, put this formula and get the answer. I think it's as simple as that. One more thing, that is the height of projectile. What? Height of projectile. If we have to calculate the height of projectile, write down the heading height of projectile. What? Height of projectile. So whenever you have to calculate the height of projectile, height means the maximum distance it can cover in vertically upward direction. This is the height. So whenever we have to calculate the height of projectile, we may only consider the vertical component. Means height is equal to u square. This is a vertical component upon 2g. Write some basic things like we may only consider vertical like this. We may only consider the vertical component if we have to derive the formula of height of projectile. Why? Because if we calculate the height, so there is no any change in x-axis along x-axis. Means we may not change any change in x-axis along horizontal component. We may only change the vertical component. So we may only consider vertical component along y-axis. So ui is the vertical component. So substitute the value of ui, that is the u sin theta. Put the value of u sin theta in equation number 1, and you may get the answer. Like this. U sin theta whole square upon 2g. The formula becomes u square sin square theta upon 2g. That's the formula of height. So if you have to find, whenever you find any type of numerical related to height of projectile, means the height of projectile, so you may put this formula and get the answer. I hope this is clear to you all. We may create a box by red color, so it is easy to visible to you. I think it is clear to you. And whenever the formula related to maximum height, so you put the value of theta be 90 degree, because sine gives maximum value at sine 90. 1 k square 1. So the maximum value of height is h max becomes u square upon 2g. Simple. So whenever you find any type of numerical related to maximum height, or you have to calculate the maximum height of a projectile, so you will simply put this formula and get the answer. I hope this is clear to you all. So my next topic is equation of trajectory. What? Equation of trajectory. Now we will derive the equation of trajectory. First of all, many of the students may feel confused in learning cramming formulas like the range, time of flight, and height of projectile. So you may always ask, okay, sir, is there any type of trick to learn these formulas in one in a less than 5 minutes? Yes. Yes, student, there is a trick. So, without wasting any time, let us know what is the trick. So, remind this word torch. Let us remind this word torch, in which the meaning of T stands for time of flight. T stands for time of flight. R stands for range of projectile. What? Range of a projectile. I hope this is clear to you all. And H stands for height of projectile. Height of a projectile. I hope this is clear to you all. So let us understand one by one. So by telling this word, we may create a sequence of T, R, and H. This is a sequence. First number we can write T, second number we can write R, and third number we can write H. So you may already know that in time of flight, in range, in height, u sin theta upon g is common in all the three. U sin theta upon g is common in all the three. U sin theta upon g. U sin theta upon g. But there is a difference in all the three formulas. Like, let us suppose a friend named 2. It becomes very close friend of 2. So it always sits with besides you, like this. So it becomes the formula of time of flight. It is as simple as that. Now it creates a friendship. It creates a friendship with theta. So it becomes 2 theta. I hope this is clear to you all. And it is already a friend of you. So it can sit in the head of you like this. So it becomes the formula of range. I hope this is clear to you all. And whenever we have to understand the formula of height, that now it creates a friendship with g, like 2g. And u square remains constant. And now it sits in the head of theta like this. So this is the formula of height of projectile. So you can remind all this formula in this sequence. So it is very easy to understand. It is very easy to learn as well. I hope this is clear to you all. Please note it fast. So my next topic is equation of right on the heading, equation of trajectory. Trajectory means the path which the projectile is to be followed. So whenever we have to derive the formula for equation of trajectory, so it is very easy to derive the formula equation of trajectory like this. We submit the word. Let write on the heading equation of trajectory. Very easy. Equation of trajectory. So let us suppose this is the object O. Let us suppose be a ball or a stone or anything. So we can throw this object along x-axis with the initial velocity du, and it makes an angle theta with the x-axis, and this is the along y-axis. I hope this is clear to you all. And this is going like this. I hope this is clear to you all. This is the range, total range by which a projectile is to be covered. I hope this is clear to you all. This is the x-axis, this is the y-direction. The component along x-axis is ux. The component along y-direction is uy. The value of ux is u cos theta. The value of uy is u sin theta. I hope this to be clear to you all. So we already know that the horizontal component remains constant at any other point like this. The horizontal component remains constant at this point, and it becomes 0 at this point. Uy becomes 0 because we may feel a type of acceleration that is minus g along